CA conference 2 years ago in 2019. I also have to give you a special thanks because there were a couple of questions there that pushed me in a direction I really had not expected to go. And those questions and your kind of push has a lot to do with why this website even exists online today, because had you not pushed me, I probably would not have built it, to be perfectly honest. So thank you very much for giving me that just little bit of push to get me to do something that I'm actually glad that I've done. So before I actually tell you about Firefall, I'm going to actually switch my screen off, and I'm going to share my screen with you. And I'd like to kind of give you a brief history of Firefall as a way to explain what it's about and how it can help you, because I do think it makes a difference if you understand how it came about and some of the critical elements that shape the way it's built. So I'm going to turn off my camera here and share my screen with everybody. Can everybody see my screen?
Yep.
Yes.
Okay, perfect. So I like this motto, Firefall, where fun plus practice equals brightness. Because I think it's if you're not having a little bit of fun, and not necessarily fun because you're doing something silly or crazy, but just simply fun because you really realize you're gaining something valuable. And if you're not practicing, if you're missing either one of those two elements, I don't think you get the final end result of everything. So let me see here. The reason Firefall exists is because I wanted to build something that would help people like me. And when I say me, I mean both the me that was a student once upon a time and the me that was a teacher for 25 years. When I first came to teaching, I hate to admit it, but I was a little bit, I was a bit of a elitist. I think that's probably the best way to put it. I just graduated from the Naval Academy about 10 years prior. I had majored in physics. I wanted to teach all the honor students and AP students, and that's what I was going for. And I happened to end up at a small school in New Jersey called St. Pat's, which you may have heard of because of their basketball team.
Oh, yes.
And Sister Dorothy insisted in my second year that I teach a class of students with learning disabilities. And I hate to say it, but I did not want to do it. I tried every excuse under the sun to get out from underneath doing it, and she insisted. And I was in the class for about 2 weeks. I was not enjoying being there because I didn't feel like it was a solid use of my education. I didn't feel like they were necessarily learning what the amount that I thought they needed to learn. And after about 2 weeks, I had this epiphany. I kept like, why do I not want to be here so much? Why does it bother me to be in this room with these students so much? And it finally occurred to me that the reason was because these students were me. I actually started out with, well, I didn't start out, I still have it. I'm dyslexic. I didn't learn to read till I was in 3rd grade. I had a speech impediment. And I realized that, sometimes you're so ashamed of something, you're so ashamed of your inability to do something that you run far and fast from it. And eventually you forget that you're even running. And I realized when I was looking at these students that I was really running from people who reminded me of me. And once I realized that, it gave me what I needed to realize what I think teaching is about. And it's to help people find the strategies that they need to be successful, because everybody can be successful. You just have to have somebody to believe in you and who can give you a methodology that works for you. And so I created Firefall for the students to kind of help teachers find a way to give students the strategies necessary to get them to where they needed to be. The other reason, the second reason I wrote the program is because I wanted a program that would do what a real teacher would want, not what some programmer in some back room who had never taught a day in his or her life imagined us teachers would want. So imagine if there was a way to get students to show all of their work. Imagine if somebody wrote a program that made that possible. Imagine if there was a program that could get someone to grade every step of most homework assignments for you with a brief written explanation of each error. Imagine if you could instantly know what each student doesn't understand, even if they couldn't explain it to you. Or if you could have your own in-class support teacher that was endlessly patient, encouraging, and kind with even your most difficult students. Imagine if you could cover twice as much material in half the time with deep understanding, or improve your classroom discipline, or get your students to love math because people love what they're good at. Firefall Math was built for those two things, to help students and to help teachers help students. The second reason I built Firefall Math was because of a kind of a really nice coincidence that made all the difference at just the right time. When I started off at St. Patrick's, for most of the years that I taught there, when our students came into ninth grade, they were a year behind. Ninth graders were on the eighth grade level, and no matter what we did, when they graduated 4 years later, they were still a year behind. I mean, they were at the 11th grade level, but they were graduating, you know, at the 12th grade. Nothing we could do could change that. And at one point, once the administration trusted me, I asked if I could, one second, I'm going to admit somebody here. I asked if I could teach a computer programming class to all incoming ninth graders, and they allowed me to do it. The thing was, when we looked at the results at the end of the year, that ninth grade class, when they took their Terra Novas, had made a 1.7 year gain in their math performance. And so you've got to ask yourself, and I certainly asked myself when that happened, what was it about teaching them programming that made a gain like that possible? This is a little piece of programming code, and I'm going to use it to illustrate the three things that I think made a huge difference. The first thing was, you can easily see the structure of what the programmer is thinking here. It's colorful, it's very visual, there's absolutely positively no skipping steps. So students who program learn to visualize the patterns that make their thinking, and they learn to break things up into step-by-step pieces. There's no getting around that. The other thing you'll notice is that every line of code starts with a word indicating that what the programmer is about to do. Programs are actually a lot like geometric proofs, where no action can be done without giving your reason. And since there aren't very many reasoning words or keywords, you have to get very creative with how you use them. So programming forces students to truly be creative instead of just repeating what the teacher does without understanding why. But the most amazing thing about this is, if you look closely, most computer programs are created with very, very few words, very few keywords anyway. So if you look at this, there's an if here, there's a let there, all these words in purple and blue, they're the main keywords. And in most languages, there's at most 50, but often barely 20 or so that you have to be able to use to write an effective code. And so I began to ask, are there key concepts in math that if you learn them, everything else would be almost extraneous? If you get those key concepts, you're going to be successful, because you can tie them together and create a fashion to do everything else that looks more complicated, but really is just a combination of simple things that you've gotten used to doing. So I called the skills that I finally came up with Ecritical Skills. And the reason I call them ecritical is because when I speak to people about them, I usually introduce them with a game to drive the point home. And the game is simple. I'm not going to do it here because just for time's sake, but I'm going to describe it. And so what I'll usually do is I'll ask if everybody has a pencil and a piece of paper, and I'll say, okay, I want you to write me 3 sentences, 7 words long minimum each, and I want you to describe your morning. And I'm going to give you 1 minute. And just as I'm about to say go, I stop and I'm like, oh, I forgot one thing. I want you to remember that no word can use the letter E. And then I'll say go. And I've done this for well over 1,000 people. And if there were 10 who were able to complete that challenge in under a minute, that would be a lot. I don't think there's ever been more than 10 total that were able to get it done. The point being, you can know 25 other letters of the alphabet, but if you're missing the letter E, you become almost instantly illiterate. And there are some skills in math that are just that critical that if a student is missing them, everything else, even if they know it well, just falls apart. And so it took me almost 5 years to discover what I consider the most important ecritical skill. I had a group of low-level students and my boss was upset that we weren't making it through the entire book. So before the beginning of the next year, I asked myself if there was something I could de-emphasize so that I could move faster. I ended up getting rid of solving equations by elimination because I felt solving by substitution was a more universal skill. And students seem to have far more trouble with it. Even though that never made sense to me, I knew that I probably, if I was going to emphasize something, I would need to emphasize that. So that's what we did. And that's the year that I realized substitution is probably the single most important operation in mathematics. And yet we don't formally teach it until we hit high school. And I want to show you like the implications that I began to realize about that. So if you look at this, this is 3 + 2 = 5. Simple problem. That's the way everybody gets taught in elementary school. And maybe sometimes they go across the page and they have an equal sign. But this subtle shift takes place when you get to high school, or even when you get to middle school. And all of a sudden they give you this problem. They don't have an equals, they don't have a little bar, they just give you this problem and you're supposed to know what to do with it. And I mean, to most of us, that's like, well, obviously you're going to add it, it's going to be 5. But then we do this. We put the 5 below, and kids have never seen that. And a lot of kids don't realize that what you actually did is you just substituted in 5 for the 3 + 2. And right there, they begin to get lost. If you think about what we do, we write all of our equations across the page, and then we work certain operations in order. But a lot of students get lost in that process because they don't even realize what's changed and what happened to what changed or disappeared. Now, the standard thing that we think of as substitution is this, where the x is going to be equal to 4, and then we're going to substitute it in, and then we're going to simplify the order of operations. But the more I looked at it in this particular year, the more I realized it was a lot more, it was a lot deeper than that. What I really began to realize, and when you look at Firefall, you'll see this little triangle in the upper left-hand corner of the page. And what this triangle really represents is all the different kinds of substitution that I finally came to realize were critical. So for instance, area of a square. Well, what are we going to do with that? Actually, we're going to substitute an equation for that phrase. It's not obvious that that's what's happening, but that's a substitution. Or we could think of it as a translation from one language to another. I could give you a picture, and that picture is going to be substituted for an equation. I could give you a phrase, and that phrase could be changed and substituted for a picture. And all of these substitutions bind together to make mathematics. But if you don't know that's what's happening, that you're taking a mountain and you're substituting a triangle, that you're taking a crop circle, and the only thing that's important about that phrase is circle and not crop, you don't quite get mathematics. And so Firefall is structured to drive home all these different critical types of substitution. And it's designed to do one more thing. And now I'm going to begin to switch from telling you about Firefall to actually telling you about how to use it. So we think of learning, at least I thought of learning for a long time, as something you do with your head, your prefrontal cortex, your thinking, your problem solving, you're doing all this stuff. But I think for students who are not natural at mathematics, a deeper part of what learning has to do with literally rewiring or restructuring your brain. I think the most amazing thing about Apple, their iPhone when it first came out in the early 2000s, is without people realizing it, we picked this thing up and we picked up the language of swiping and tapping. And why? Because we wanted something. And the only way we were going to get it is doing what the computer wanted us to do. The computer structured the way we were going to interact with it, and we accepted it without asking any questions seamlessly. And now we have a whole society, practically a whole world, that thinks nothing of doing this. Our brains are different than they were before that device was introduced. And this is kind of the way you can think about Firefall. It's designed to make, it's not designed to hit the front of your brain, it's designed to get to the back of your brain, the reflexive portion of your brain. When I was teaching algebra, I could put these two problems on the board, and I'm talking algebra 2, and 75 to 80% of my students would miss either one or both of these problems. Why? Not because they didn't know how to do it, but because it wasn't reflexive for them. They just kind of did it willy-nilly, and it wasn't in their bones that they absolutely have to work the parentheses first, or they absolutely can't add the two parts of the 2 plus 4 and the 2 plus 4 first. You have to do the division. They would just space it. Now, if I told them, then most of them could do it. But the point isn't so to tell them, it's that it's actually a part of who they are and how they would think about things automatically. And the way we achieve that is by ensuring that once we introduce a skill, you never lose it. So the question was, what's the first skill to be introduced? And I started with the order of operations, 3-step simplification, because if a student, pretty much every problem that you ever do, at the very end of it, you are going to have to simplify the phrase in some fashion to bring it to an end. So once you learn that and perfect it, it's going to stay perfected because you'll never stop doing it. Substitution was the next thing that came on top of that, like actual formula substitution. And then I just kept adding skills, one atop another, until we had this structure, and you'll see it in the exercises and how things get built. So now I'd actually like to show you the interface and just talk about how it gets used so that you can get the maximum effect from it. Can everybody see the website now? I'm going to pause here just really quickly. Does anybody have any questions before I go on? Okay, so I'm just going to kind of walk through this. And when you sign up, basically you'll log in. And when you log in, I'm already logged in, but when you log in, it'll take you automatically to the dashboard. And this is kind of like an overview of what the student has done, or if you've got a teacher account, the overview of what you've done, maybe the exercises you've completed with your class, and how you or they have done on them. You'll see these blue arrows, and the blue arrows will kind of lead you to where you need to go, so you won't have to remember or think about it when you first come in. So click here, takes you to the chapter section. And these are all the chapters that are coming. These chapters up here are the chapters, they're whole number chapters, the ones that we already exist. Now, the recommended chapter to go into is in green. And in this case, you can see the blue arrow there. But whether you want to go into that or not, or whether a particular student wants to go into that or not, has a lot to do with whether or not they can multiply. If you have a student that can't multiply, this chapter right here is designed to get them to be able to multiply in about 2 weeks. Just to be pretty comfortable with their multiplication tables in about 2 weeks. So I'm going to show you this first. This pops up because it'll kind of always try and nudge you in the direction that ideally you should go. But it also gives you the freedom to go where the student needs you to go. You'll notice that the multiplications don't happen in order. I start with 2. You would think, why start with 2? But I used this with the Boys and Girls Clubs, and a lot of the students were surprisingly couldn't multiply, and many of them couldn't multiply by 2s. Many of them couldn't multiply by 10s, but I picked these because these are the easiest to begin with. There's an obvious pattern to 10. There's an obvious pattern to 2. There's an obvious pattern to 5. And if you think of it, by the time you've got to 3, you're actually not halfway through your multiplication tables. You're actually 75% through your multiplication tables, because 10 times 7 is actually one of the problems that's going to be taught way down here. So very, very quickly they can get proficient. And the exercises that come afterwards are built using small numbers. I try not to use numbers greater than 5 too often, because I want them to get in the habit of using the skill of using their multiplications, as opposed to using a calculator. I want to switch real quickly back to one thing here. A lot of people might think to themselves, why multiplication? It's just memorization, but it's not. If you have a student doing these exercises very quickly, you can point out all these patterns. Like, for instance, if you multiply by 2, it's 2, 4, 6, 8, 10. And then the pattern repeats: 12, 14, 16, 18, 20. And so you can give them a way to check their answers by using this thing that we call skip counting. 10 always cycles back to 0. 5 goes 0, 5, 10, 15, 20, 25, 30. And a lot of kids think, wow, I never knew that. And all of a sudden, just seeing that it's not just something you have to memorize, but that there's an actual pattern to it, makes a huge difference in how they engage the material and how quickly they learn it. So I'm switching back to the. So when you go into one of these exercises, you'll see something like this. And there's a little lesson. This lesson's probably about 3 to 4 minutes, 4 minutes long there. And you can show it to your whole class and use it as your introduction. They're really well thought out. And so you can you get the meat of what it is you need to know. The notes are at the end, so it's kind of a summary. And then you can begin the exercise. So if you begin the exercise right here, you'll see that basically the exercise for this is to go 2, 4, 6, 8, 10, 12, and fill them in. A lot of students don't know that multiplication is just quick addition. And once they realize that, and that they can use their hands and literally count on their fingers 2, 4, 6, 8, and once they get to 4, well, that's 4 times 2. And it takes a while. You can't, like, as simple as it is to us, it takes a while for them to have all these little epiphanies. But these exercises are the way that happens. If they want a little review, they can press the review button. And I'm actually going to use this to show you a couple of other exercises.
So fast, you'll hardly.
So I just showed you the skip counting exercises. But this is another type of skip counting exercise where you actually have to count 2, 4, 6, 8, 10 in a rectangle. And why would I want that exercise? Because this is the basis for finding area and talking about perimeter, but mostly about finding area and realizing that if you have something that's too long and 1 wide, well, that's 2. If you have it at too long and it's 2 down, it's going to be 4. Too long and 6 down is going to be 6. A surprising number of students have no idea about that. The last portion of this is more traditional, and it actually lets you see and gets them used to seeing whether they can multiply and actually using the skip counting on their fingers to supply an actual answer. And I recommend that students, when an exercise is complete, you'll get a basic score here and you'll get a continuing score. And I recommend that students try and get an 85 or higher before they move on to the next exercise. Usually with the 2s and the 10s, they get 85 or higher right away, and they get that first initial feeling of success, which is what we're going for. And it builds on itself and you can go from there. So I would only recommend starting students here if they really have a lot of trouble with their multiplication. But if not, then it's better to move on right to here and move to just order of operations as suggested. Now, when you start here, this first lesson is so simple that you might think to skip it. But I didn't actually even include it when I first built this. And the reason is because I thought there was no need for it. And then I found out that I had trouble dragging in the blocks, that it actually took up space in my head that caused me a little bit of trouble thinking about what was going on. So I put it in. You'll happen to notice here that at the bottom, there's a worksheet, and you'll see a worksheet at the beginning of most exercises. So the worksheet happens after this, but what happens in this exercise is simple. You simply have to drag in the block and watch what happens. Exponents, multiplication, division, addition, subtraction, those are the orders of operation. And I want you to just get a real kinesthetic feel for it. Like when you spell a word, sometimes it feels wrong. The same thing starts to happen very early in Firefall. It's rewiring your brain just from the beginning. And once you drag this in 10 times, this sequence of blocks, and I tell the students to watch how things get simplified, ask them why is there none there, talk a little bit about that. And you just do it again. And again. Now let's suppose a student makes a mistake and they drag in, they forget what they're supposed to do, and maybe they drag in a substitution block. It says to simplify a formula, what operation should come first? Mm-hmm. And if you do it wrong again, it'll be like exponents and roots always come first when simplifying by the order of operations. This thing is like, it can see what you do wrong. And before the teacher ever even has to necessarily look at it, it can help the student move on to the next step. And they're like, oh yeah. I remember, I want to drag in exponents. And now that they're not lost, they're like, okay, they're thinking a little bit for themselves. That's right, yeah, that's right. And yeah, and then this was the next one. And then, okay, and they're on to the next problem. And by the time they get to 10, they've mastered this. They've had their first really solid success. They feel good, and they're ready to try the next exercise. So when you go on to the next exercise, it's about exponents, and you can see how visual this is, where I try and always show how the exponent turns into 2 multiplications, how this exponent turns into 3 multiplications. And the notes show that. But importantly, when you use this with students, even then they may still not get it. And so I recommend actually saying, let's expand this for a second. 3 times 3. And then why? Well, because there's 2 of them. Okay, so 3 times 3 is 9. And a lot of students do that. It becomes especially handy when you get to 3 to the 3rd or 3 to the 4th. And then you move on. Okay, any multiplication, division? No, there's none, so you can just skip that. Any addition or subtraction? No, there's none, so you can just skip that. And you're on to your next problem. Now, let's suppose again that they forget. And this time they're like, oh yeah, I know, this is 8. And then they go into dragging the next thing. Did you multiply by 2 instead of raising to a power of 2? It'll spot most of the types of mistakes a student might make. Like maybe you decide to raise this to the power of 3 and you come up with 64 instead. When you try and drag in, it'll recognize that you tried to raise it to a wrong power. It'll correct it. And so you're not stuck on that step, but then you can continue on. And the last thing I want to say about this is this worksheet here. I'm going to pull it up so you can see it. These are the worksheets for Firefall. And after working through these worksheets, students really understand that you're going to expect them to show every step of every problem. The answers are at the end because we don't care about the answers. It's about the journey to the answer. And this basically shows you how everything fits together. I usually add 1 more or 2 more problems at the end. And I personally write them out for the students because what I want to see is if they'll do the problem without me having to ask and show all of the steps. And if they do that, you know that's it. You've got them. From that point on, they can actually begin to move forward on their own. And the program is smart enough that you can help them without necessarily having to always be watching what they're doing. So I wanted to show, let's see. I wanted to show when you have a teacher's section, you might wonder what's happening to all of these errors. And what's happening to all these errors is if you have a teacher account and you've signed your students up, I'm going to go into, these are classes, and you can see kind of where the class is at. The large green checks mean that they've got it. The small green checks, or maybe the dots, mean that they're on their way, but they're not quite there. The reds mean that they've started, but maybe only a few people in the class have started. If you want to see what the percentages are, you can check here, and it shows you the percents. But the real beauty of this, and I wanted to show you this specifically, is if you click onto a class, and I put this in especially with this one student, and you go to the student and you look, you get an overview of the 19 critical skills the student has been working on. And if you click into this, here's all the mistakes that that student has made on that skill. And you can very quickly see, wait a second, you know what? Multiply, let's see, multiply by 2 instead of raising to a power of 2. Oh, there it is again, multiply by 2, oh, multiply by 3 this time. And you realize, you know, this student is only doing one thing wrong, really. They're just multiplying instead of adding. They keep forgetting. You know, that you can kind of see that they're usually getting it right, but every once in a while they forget. And you just remind them of that little thing again, and gradually those red X's will disappear. And you'll know that they've got that skill, and they can start focusing on the next. So that's how this works. And it gives you this ability to really diagnose how a kid is doing and precisely what it is they're having trouble with. And from there, it just builds. If you look at this as a parentheses exercise, and you'll notice that you're actually pulling in the same blocks as you were to simplify a basic exercise, because a parentheses is nothing more than a little problem. And you have to do exponents, multiplication, addition, subtraction with each one before you substitute in and finish off. If you go a little further, you get to substitution, where they actually have to substitute into the equation. So for instance, there's this equation, and you go in, you pull in the substitution block. I've structured this so that you don't have to do a lot of copying or typing. For instance, you literally can just do this, and you've got that whole equation down here for yourself to work with, and you can put in, whoops-a-daisy. You can put in the 2 times, and for the J, you can put in times 2. And actually A is 5. Let's leave it and make it wrong for a second. And then you can do I is times 1. And when you get ready to drag in, it'll ask where one or more of your substitutions wrong. You'll be like, oh yeah, I messed up my J. J should actually, I'm
Rodney,
sorry.
I lost your image.
You lost my what?
Image. I can't see you.
Oh,
I just have a black screen with your name on it right now. I can hear you, but I can't see what you're doing.
okay. Let me go back to,
I had you perfectly all along, and then just now the screen just.
okay, is that happening with everyone?
Yes. Thank you, Mark.
No problem.
Okay. Well, I'm near the end of what I wanted to say with this.
Okay.
Let me leave and see if I can share my screen one more time. So can you see it now?
Yeah, we're back.
Thank you.
Okay.
Thank you.
So the only other thing I really wanted to show you, because I wanted to leave time for some questions, is gradually the problems move into word problems, and there's 5 categories of word problems. There's 3 levels of direct translation problems. There are given formula problems, standard problems where you have to kind of memorize the, you should have the problems memorized, like area equals length times width, or maybe the percent, or right now they're simple: circle, area of a circle, perimeter of a circle, area of a rectangle, perimeter of a rectangle, and same for a square, and single change. And so when you begin, you need to recognize, okay, this is a direct translation problem, and I've got to highlight the key phrase here, 3 times a number equals, and it'll auto paste in there. If you try and highlight too much, okay, if you do something like this, where you're like, well, I'm just going to highlight the entire first sentence. When you try and drag in, it'll notice it, and it'll ask, did you select a bit more? Now to start off, I highlight them for you, so you don't feel completely lost in the exercises. But as you move to the next exercises, they're not highlighted at all. You have to highlight them yourselves. And that's true of every type of problem. Even if you end up with a given formula problem, you have to recognize, hey, I'm given formulas. So this is a given formula problem, and I just have to find my keyword, which is down here. And the keyword is perimeter. Okay, so once I've got that, I can drag in, and let's see, you have to work in order. So since I know I'm going to use the perimeter formula, I want to find my length first. You find the length is 6. Then you go to given formula, and you find that the width is 10. I'm sorry, the width is 4. And then you drag in and you translate. Area is going to become that. I'm sorry, perimeter is going to become that. And then, and this is the last thing I'm going to show. When you drag in your formula block, I really, really want to drive home that formulas are abbreviated versions of English. And so you can either come over here and say, I want my length. So my length is going to be, and I want it to be 6, a length of 6. And then I want to translate this into a width. So you could also come here and go a width of 4. And then you go into substitution, and you can see how this all gradually builds on itself higher and higher and higher. There's also a graphing section, but I'm going to stop there and just transfer this back and basically give you a chance to ask any questions if you have any.
Thank you. That was great.
Do people have any questions or thoughts? Or
is this the type of software like you can run off of a server? So like if we bring the students to the lab, they will be able to access this, or do you have to be connected to the internet for it?
I'm going to give 3 answers to that. Answer number 1 is you can download it onto a computer, but only a single exercise. So I don't know how the computer lab works, but if you have laptops in the computer lab, you might be able to access the internet before anybody's using it and download each particular lesson. Or as you saw there, I actually downloaded several different lessons. And then you could use it that way. You can download the videos onto any computer. In terms of whether you can actually download it onto a server, the whole thing, I don't know, but I also am not 100% certain that you can. So does that answer your question?
Yes, it does.
I'm going to definitely check on that and see. But at this point, I don't think so.
I think another solution could be is to tell your IT people that you need access to this specific website, and they can set it up for you on your server. And that's what we may have to do over at JJC at some of our locations. We may have to have our IT people give us access specifically to this website, and they can do that. But that's something that they're going to have to do on the IT side. If when we go into the classroom, we try to use it. If we're not able to do it, we're going to have to put in a specific request to IT to allow us access. Okay,
that would work. And the other thing is the way this is built, because it wasn't built this way originally. And again, I have to say thank you for all the input you've given me over the years, because this has changed many different times, always with the thought in mind of trying to like make it usable based on comments that different people were making at different NGA, CEA conventions. Nothing is connected to outside. So like I don't use YouTube, so you don't have to worry about all of a sudden them being able to like move out from YouTube. We use Vimeo. There's no commercials, there's no advertising. I'm not trying to make money that way. I'm just trying to make it accessible to as many people as possible. And this is also, if your bosses ask, everything that I showed you just now is free, and it'll stay free pretty much always. Some of the later modules I'm going to charge for, but not a huge amount. Like, is probably maybe $2 per module per student is kind of where I'm like looking at. So I think it should be affordable for everybody.
That is amazing, Rodney, because I know corrections has looked at a lot of different software for reading or for math or for science, and it's a lot more than that.
The one other thing I wanted to add is the section I just showed you lays the template. And for many students, once the template is laid for like how math fits together, that's all they need. And they can progress very rapidly through whatever it is you give them after that. However, the next module is about negative numbers, and it takes everything that we just did and it just does it with negative numbers. It starts with a basic exercise to really teach students a simple way of doing negative numbers. And in a week, you can teach negative numbers, and I can pretty much guarantee you that every student in your class will be able to do negative numbers at nearly 100%. I mean, that's just like an ironclad guarantee. But that skill is not necessarily so useful unless your students are looking at maybe taking a college course or taking a follow-on course, because I mean, realistically, a lot of places just let you use the calculator even on the test. And so if you have trouble with negative numbers, you can get around it that way. The key module, I think, for really cementing success, like successful GRE results, like successful SAT, like really moving the needle on everything, is the third one on fractions. Because fractions is pretty much the greatest indicator of student success. Once you get fractions, like part over whole is a fraction. Part over whole is probability. Part over whole is practically everything. Part over whole times 100 is percents. The only thing that's a little different is ratios, which is part 1 over part 2. But when you hit fractions, you just pull in this huge amount of information that's questioned, that's pretty much everywhere. GRE, ASVAB, just everywhere. So that will be coming in about 9 months or so. That's my hope.
Oh, that's great.
So thank you. I like really thank you very much for taking your time out of the morning. Thank you for your questions and your input again. Thank you, Kevin, for inviting me and allowing me to share your space. Move my camera down a little bit.
Mr. Weems?
I really appreciate it, and I wish you guys the best of luck with the rest of your school year. I know the different circumstances with COVID are difficult, but I really admire what you're doing, and thank you.
Do we have any other questions before
Yeah,
we sign off?
one item. Are you there?
Yes.
Okay, Mr. Weems. The rectangle, the area of a rectangle, you know what the area of a rectangle is. And then something to keep in mind, like geometry. If you draw a diagonal on a rectangle, what does that relate to? It's two areas of two triangles. One half times BH is 1/2 times the width times the length. If you double that, you get the area of a rectangle, something like that.
And it's interesting that you point that out, because The reason I didn't include rectangles is because rectangles have fractions. So areas of rectangles don't actually come in until the fractional section. Because I want people to actually like understand the fractions they're using before they're actually trying to manipulate them. But thank you very much.
Any other questions? All right, just to let everybody know, I did record this. So I'm going to put it on the website. If you haven't been to our website before, it's www. C as in cat, E as in Edward, A as in apple, region1.org. So as I said earlier, we're part of the Correctional Education Association. Region 1 is the Northeast, Eastern Canada. I know a lot of you recognize your names from sending emails. The way it's set up is if anybody missed this workshop, it's going to be on the website. I'm going to say tomorrow because today's a nice day. I want to get outside after this, and I'm sure you all want to do something else. But I'll work on it tomorrow. Get the recording set up and put it on the website. And then that way, if anybody, I know supervisors. I was talking to some people from Massachusetts the other day, and their supervisors are using these training workshops that we've put on. We have like 12 from National Correctional Education Association, and we also have about 12 from New Jersey and Region 1, and they're all free. So if somebody needs training hours, they can go on during lunchtime or go on whenever and check out these different workshops, write 2 paragraphs, send them to me. You know, what the workshop was about, and the second paragraph, how I could use this or not use this in my teaching. And then I'll send you a certificate so you get an hour of training. These are all free trainings. Our organization is nonprofit, so we do have a membership of $65 a year, and that's for the national, or actually the International Correctional Education Association. Thank you very much. I really appreciate all your time. And I'll hopefully, if someone would like to volunteer to do another workshop at some point, well, we'll definitely do it. If there's a better time for us to do it, if you don't want to do a Saturday morning, if there's a better time we can do it, please let me know, and we'll try to shoot for a time that's good. But please let other people know. We had like 20 people sign up, and I know it's Saturday. Everybody's got different things going on. But please let people know that we do these workshops whenever we have someone who's willing to share. And I see a lot of familiar names on the list of participants. So maybe somebody else would like to do a workshop at some point. But thank you, everybody. Have a great weekend. I appreciate your time. I'll get the certificates out to you within tomorrow, and get the recording on the website as well. I see a thumbs up. All right. Well, thank you so much, everybody. Be safe and be well.
Thank you.
Thank
Take
you.
care.
Have a good day, Rodney. Thank you very much.
You're welcome.
Good day.
Take care.